Cool. Thank you everyone for coming. My name is Azriel, and today I will be talking about my automation framework called Peace. So before we begin into the looking into the framework, I want to share with you two stories. The first story is when I worked as an automation tool developer at a place called Orion Health, and within a team of 3, we created a tool which packaged our company's products into a single package. We could launch some environmental servers, deploy the products onto those servers, and make them talk to each other. Now, the good thing about this was we took the deployment time, the setup time for these environments from 2 weeks down to 2 hours, which is like good. But what was not good was our users couldn't enjoy this tool. And the reason why is, first, when they were using their manual workflow, they would have their work going like this. Step 1, step 2, step 3, I made progress, progress, progress. But when they use our automated tool, it was step 1, fail, start again. Fix the issue, step 1, step 2, fail, start again. And so they went step 1, 2, 3, and we had a lot of repetitive work. And so every time it failed, it was not just the repetitiveness that made people feel, oh, I failed, I failed, I failed. It was also that they did not understand what was going on. And whenever it failed, it would be, I need to figure out what this technical error means. So they could not understand what the state was of the environment. So from that, I learned 2 lessons. So the first lesson is, when you introduce change to someone's life, make sure it enhances their life. Because if you introduce change and they feel like, oh, I feel worse than my manual workflow, I want to go back. Yeah, so that's the first lesson. The second lesson is, it's not usually the one big failure that people feel like, I'm sad. It's usually the 100 little failures that when they hit each failure, cumulatively, they feel like worse, 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 until I give up. Because cumulatively, they feel so many failures, the next time I run it, it's going to fail as well. And I'm going to be frustrated trying to solve that problem. So our tool kind of failed in 2 major ways. The rest were minor. So the first major way it failed was, it was inefficient. It was repeating work that did not have to be done. So step 1, step 2, step 3. If I fail on step 3, don't redo step 1 and 2. But we just had this cleanup work done, so you had to redo the work for step 1 and step 2. And the other way it failed was, we failed to communicate state. We failed to communicate progress. So people kept feeling like, I wish I understand what's going on. I want to do the right thing, but I cannot. So that was the major learnings from this role. Now, the second story I want to share with you is when I was a DevOps engineer. And this was my first time being on call. So how many of you have been on call? Wow. All right. So I guess you know. But the first call out, the very first call out you get is the most exciting, because you don't know what to do. Yeah. So it went kind of like this: beep beep beep, database ID, blah blah blah. CPU utilization's too high, and I didn't know what to do. So I was like, okay, first step, maybe I will reverse trace from the database ID to which customer it belongs to. And from there, I had to forward trace from the customer ID to all of the resources in the environment for that customer. And then try and solve the issue. Now, this tracing was gathering information. And for that job, it was kind of like cookie clicker. The more you click, the higher you score. But for a production alert scenario, the more you click, the slower you are, so the lower your score. And I was losing. So I want to cut the story short there, but the learning I got from this role was, gathering information is a process. and processes can be automated. So why not just automate the process of gathering information? Because we automate the creation of these resources, we should be able to automate the gathering of the information of all of these resources as well. So that was my second big learning. So at this point, I'm going to share the screen and talk about the PEACE framework. So many Azraels. All right, so if you go to peace.mk, this is the website for my framework, and it says PEACE is a framework to create empathetic and forgiving software automation. And there's a dove on screen, but I also made one here, so I was like, yeah. All right, so I know I can tell you what empathetic and forgiving software automation is, but better than tell you, I will show you. So today, I'm going to show you a tool. Just zoom in a bit. Hold on. There we go. So I'm going to show you a tool called EndMan. Maybe a bit hard to read, but maybe that's a good thing. I'll explain why later. So EndMan is a tool created using the PEACE software, PEACE automation framework. And on its own, the framework does nothing. But if you plug in your logic to the framework places constraints on your logic such that it shapes your logic and your data types to be resilient and presentable to the user. So hopefully, if you create your automation tool using the PEACE framework, what comes out at the end is something the user can feel joy to use. So let's begin this live demo. So it's a bit off screen. I guess it's all right. Cool. So just like Git, Git has a git init command which initializes a project. EndMan has an EndMan init command to initialize a project. And there's some parameters to tell it the environment name and what apps to download and deploy. Now, if you are managing an environment, the first step you want to do is understand what's the current state of the environment. Because if you are going to change the environment, it's unsafe to change the environment if you don't understand what it is. So just like Git has Git status, EndMan has EndMan status. So you might not be able to read that, but it says I'm using profile demo, the development type environment, and there are seven, there's numbers here, but you can't see them, but there are 7 items in this environment that I am managing. And because it's an empty project, the current state of the environment is nothing exists. Now, if we were to deploy this environment, we want to know what's the destination state of the environment. Because if we start at a source state, then if we go somewhere, we need to know our destination. And for that, EndMan provides an EndMan desired command. Well, there we go. So maybe maybe still hard to read, but for every single item that is managed in this environment, it tells you this file containing 6 megs will be downloaded. And these resources in Amazon should exist, and so they should be created. Now, in Git, you've got a diff command, and diff means we'll take our destination state and subtract our current state, and any differences should show up. So EndMan likewise provides a diff command, and the diff of a file to download is we're going to change from 0 bytes to 6 megs. And all of the Amazon resources will be created. And some things we can't calculate the diff because, for example, how many files will we extract out of the file that we have not downloaded? We can't calculate that. So some of these diffs will show up as unknown. And before I deploy it, just want to mention that because Peace says it's meant to create empathetic software automation. So to be empathetic to DevOps engineers, before they change an environment, before they do anything risky, the manual workflow would be, I need to know what step to do and how to do it. But then the automated workflow is, I need to understand the current state of the environment and make sure I know everything that will happen in the automation before I run it, because that de-risks the automation execution. And by presenting all of this information to the user, you can help them decide, make the decision. And so with all of this information surfaced to the user, hopefully they're not confused when they run any automation on it. So we're just going to run the deploy, and you will see that there's some progress bars, and each of these items get created. And nicely, they all link to all of the things in Amazon. So I did not have to do any manual work to discover each item in this environment. They're all linked. And see, I'll zoom in a little bit, but this is the IAM policy that got created. And for the S3 buckets, whoop, there you go. The S3 bucket. So the S3 bucket gets created, and the file that we downloaded from GitHub will be uploaded into this bucket. And so none of this demo is fake. So I want to make that point, because what you will see after this is truly how people experience automation. Okay, so now we know that this is real. When you are an automation software developer, sometimes when you create automation, you forget to clean things up. And so if you're creating things in Amazon, which is a cloud provider, not cleaning things up means paying money. And so if you pay money that you are not using, or that doesn't provide value to you, that's going to cost the business money that it shouldn't be spending. And so what Peace does for the automation developer is, for every item that you create, you must pair it with a corresponding cleanup function. So when you create some resources in Amazon, everything will be cleaned up when you tell Peace, please clean up my resources. And we can run this, and when it's done, you will see that things do not exist. Oh, actually, there's one more thing that should be shown. So when we do create our environment, our diff should tell us nothing needs to be created. So if we go diff, you can see that everything is up to date. And if you ran status, it will link to all of the state for the environment. So this is instant feedback. You don't have to go and discover, you don't even need an internet connection to see the status. So to prove that point, I'll disconnect my internet. I've never done this with my phone tethered. All right. So of course, we can run status, it'll just work. Now, status says these things exist. But what if I try to clean up these things when I'm not connected? So you can tell, oh, look, our automation itself did not crash, but you get red bars for the things that failed. So that's good feedback to the user. They can understand which steps failed. And crucially, you have a summary of errors. And this summary of errors will give you an English level error message you can understand. Like, make sure you are connected to the internet and try again. And yes, we still include the technical error in case you do need to feed that back to your technical teams. So failed to look up address information, temporary failure in name resolution. That's not going to make sense to like everyone, and certainly doesn't make sense to a sleepy me. All right, so we can turn this back on. And I kind of broke script, but one of the things that Peace does is it's forgiving. And when you think about forgiveness, the precondition for forgiveness is something's gone wrong, or someone misunderstood something. So at work, misunderstanding can come in the form of, I wanted to do work, but I did not understand the correct state of the environment. So I might have pushed the button to deploy something when it wasn't ready to be deployed, or maybe it was already deployed. So what if, so right now the status of the environment is things exist. If someone goes and says, let's deploy the environment again, let's try that. Now, Peace knows that because some of these steps have already been done, there was nothing to do. So if you had automation which created 10 servers, pressing that button repeatedly, because human nature, it didn't work, let's try again, pressing that button repeatedly will not create 10, 20, 30, 40, 50 servers, right? That's going to cost your business a lot, and it's going to be a headache. So that's, I mean, the business cost is money, but the headache is you feel bad, and that probably feels worse than the money. Right, so if you run your automation multiple times, it's just going to be forgiving of your misunderstanding and say, oh, there's nothing to do. Cool. So there's another case where maybe someone's thinking, oh, let's run this automation with these parameters. I'm going to reset the state. And what if during the work of your automation, you change your mind? Normally, that would mean, oh, we have to wait till our automation completes completely, clean up to the 0 state, and start again to where we realized that our mistake happened. So let's imagine, and let's not even imagine, let's do this scenario. So let's deploy, and in the middle of deployment, we'll interrupt our operation because we know something's wrong. Cool. So I've interrupted the process, and you can see that I only have downloaded my file. I've done some of this resource creation in Amazon, but some of the steps haven't been started. Now, the cost of interrupting a process, it could be, well, if you have a 1 hour long process and you interrupted it at half an hour, normally you'd have to go, okay, let's clean up the automation, let's clean up the state, and then let's fix our parameters, and let's restart. And I need to wait for half an hour to get to the point where I was before, and then from that point on, I will have made some valuable progress. Because if I change my parameters, maybe there's some work that I did before which could be reused. But for automation that just cleans up everything, you're wasting all of the work that you had done to get to that point. But with Peace, what you get is when you run deploy again, because 3 and 6 had steps 3 and 6 had been done, we do not need to redo this work. Only the steps that had not been processed or any steps that had been altered by a parameter change need to be reworked. So if you run deploy, you can see that, or you will see that, there's nothing to do for 3, 4, and 6. But then for the items that needed to have work done, those are processed. So you have not wasted anything by interrupting the process. So that way, your change of mind is even if it might have been a mistake, it's not punished. It's like forgiven. So one other case where you might change your mind is we sold this environment to the customer. They've used it for a while, but they don't need it. Let's clean it up. And you run clean, but while the automation is in progress, you change your mind and go, actually, the customer still wants your data. So let's do that and let's cancel. Whoops, I pressed the wrong keys. All right, so we've canceled our automation, and you can see that 1 and 2 have been cleaned up, 7 has been cleaned up, and some things were halfway cleaned up. They may have been cleaned up, we don't know. Now, if you have flaky automation or if you have subpar automation, you might be scared, like, what's going on with this environment? But because I'm completely at peace, I'm happy to go, all right, we can reinstate this environment to its original state, and whatever things were not cleaned up, we will reuse that. And whatever things were cleaned up, we do have to recreate that. But at least we do not have to throw everything away and start from scratch. So this way, we have saved a lot of effort and time. And of course, business always profits from that, and people have peace of mind. So that's the benefit of using resilient automation. Now, not all mistakes are human generated. Some may just be flaky environments. So earlier you saw how we recovered from a disconnected connection before we executed our automation. Right now, I want to show you how we can recover from disconnecting our internet connection in the middle of our automation. Live, right? So I'm actually going to start from a clean state because it's a little bit more interesting. Cool, so deploy. So ready, turn off. All right, so at this point, we've actually disconnected from the internet. And we're not streaming, so that's fine. So steps 3 and 6, you can see they were done. And step 4 was in progress. And 1 was in progress, and some haven't been started. Now, Peace doesn't actually have special handling for this, not yet. But what we could do is, because we track the elapsed time, we can track historically the elapsed time for each of these states. And if your current elapsed time has exceeded the previous execution's elapsed time by maybe a factor of 2, then perhaps we'll show a message to the user. This appears to have stalled. You may want to stop this and start again. So something interesting happens when I reconnect this. I'm not sure if it'll work on this because I've never tried it on the tethered phone, but sometimes this actually recovers and completes itself. And I was very surprised the first time I tried it. Oh, look, all right, so no automation does that for you. And I didn't even code that. I was really surprised. So that's like, yes, win. Okay, so just to clean up before I show you how this all works. Okay, so how does Peace make this possible? Okay, so if you go to peace.mk blog/conceptual introduction, that's the current latest blog post, you will see this as well, so don't worry if you can't read it. So I want to create, in your minds, an automation model. So normally, we think of automation as do step 1, 2, 3 until it's done. So here we have a process of compile an application, launch a server, and upload the file that we compiled into that server. Now, normally we think of each of these steps as a write function. So compile the application, write to disk. Launch the server, write to Amazon. Upload the file, write from disk to the server in Amazon. And these functions are linked together using, well, you have your control flow, but you also pass information through the steps. So the path for the application compilation and the IP of the server are taken from the first 2 steps and passed into the 3rd step. These are all write functions. Now, instead of having just a write function per step, we're going to have read functions for the steps as well. So your automation is 1, 2, 3, write, but we're going to have read, write for each step. So 2 read functions, 1 to read the current state, one to read the desired state. And then you've got your write function, which is to apply the change. So reading the current state, you need to define what the current state is. And for application compilation, what makes sense is, what's the last time I compiled my application? And the desired state is, what's the last time I changed my source files? Because if I change my source files, my source code, then I want to compile my application after I've changed my source files. But if my application was compiled after that, then I don't need to recompile it if my source files have not changed. So we've got our two read functions and our write function, and we do that for the server and the file upload as well. So for the server, it's what's the current state of the server in Amazon. It may not exist. What's the current state of the server? Oh, what's the desired state of the server in Amazon? And you might encode this in a file on disk. Like, I want to have a Linux machine with 16 gigs RAM and two CPUs. That would be the spec. That would be the desired state of the server. And then we have our write function, which is turn the current state into the desired state, which is launch that server. File upload will be similar to the file compilation. Maybe so if your file content in your server is different to the file on disk, then we want to do the upload. If it's the same, then we don't want to do the upload. So we just use MD5 sum for that. Okay, so with the current and desired states, you can compute a diff. And so with this diff, we can decide, is there any true difference between the current and desired states? If there is a difference, then we will have a check function which says, I'll take in the diff and tell you whether we need to do the work. So that means if the application has been compiled after the source files have been changed, then I do not need to do the work to compile the application because it's already done. For the server, if the server already exists in Amazon and it matches the spec on disk, then I do not have to launch the server. Cool. I'm going to skip past the file upload. So now we have 5 functions per step. And to feed these functions into the piece framework, we need to create a trait, because the piece framework is implemented in Rust. So Rust's way of generalizing all of these functions and data types is to use a trait. Or at least that's the way I've chosen. And you can see this isn't the real code, but close enough to the concept that if you have an item spec, which is my container for these 5 functions, and the types for that each function returns, then piece is able to call these functions when it wants to retrieve the current state, desired state, diff, whether it needs to apply the change and the actual application of that work if needed. Now, when you have all of the logic, you need to also tell piece what the ordering is between these steps. So instead of having a linear step 1, 2, 3, 4, 5, piece uses a graph. And so over here, we've got 5 steps. Each step has 5 functions. So we've got step A saying A must be done before we run steps B and C. But B and C have no dependency between the two. So we can run them at the same time. And so on and so forth for D and E. D just needs to wait for B to finish, but E needs to wait for B and C to both complete before we run it. And the reason we do this is we can get some performance gains by running things at the same time. And we do that through Tokyo. We use asynchronous calls for running these concurrently. And if you use the multi-threaded executor, they should run in parallel as well. So it's quite hard to film it on screen. I've tried. Okay, so the last bit, just because you have 5 functions per step doesn't mean you have to run all 5 functions per step. If you have the current state function, if you run the current state function for every step in your process, then you can discover the full state of your environment without ever writing to it. So this is a read operation. It's safe for DevOps to use. Usually it's safe to do reads without any writes. And so if you want to know what is, then you run the current state command through piece, and it will tell you, here's the current state for the environment, and you have not mutated the environment, so you are safe. And Likewise, you can do it for the desired state as well. What should the environment be without changing the environment? And once you compute the diff, then you can display that to the user, and then they can go, all right, I think it's safe to run the automation. And we run apply. Now, how the resilience works is when we slash our automation in half, let's say between these lines, then the next time we run the automation, we know that the first three items, the current state is the same as the desired state. And that's why when we run the automation the second time, we know there's no work to do for the first three steps. But for any remaining steps that were not executed in the first run, we will run those steps. And so that's how we reach the desired state idempotently. And likewise for clean, we also have a current state, which is the same as the first flow, but the desired state for clean is actually the nothing state, the empty state. So our target state when we run clean is we need to make sure nothing exists. And we actually run the application of the logic in the reverse direction. So that means I will clean up the last steps before I clean up the first steps. And the reason for that is if we wanted to clean up, let's say we uploaded a file to our server, and then, well, the server had to be launched first. So if we kill the server before we try to clean up the file, we know that, we can't even connect to the host. But it's kind of better to, I know sometimes you might not care about that file being cleaned up, but it's cleaner in the sense that if you wanted to recover your environment to the state that, the fully deployed state, so if you started your cleanup process and you wanted to go back, at least you know where you are and you've cleaned things up properly. Okay, so I guess one note is the apply command and as well as the clean command. We will run current desired diff check and apply all 5 functions every time, because even if you know the current state, between you running that current state and apply, maybe someone else has applied. So to be safe, we need to check the current state at the point of execution of the apply. Cool. And just to end this talk, I will end with 2 notes. One, is peace ready for you? And I'd say not quite. So yes, the demo was pretty slick, but the thing that it's not ready is, one, the APIs are not stable. While building the demo, I realized what I wanted to improve. And the other thing is it only works for static workflows. So if you add steps or remove steps, peace doesn't work so well with those cases yet. So I think that's necessary before we actually use it in a general sense. And the other ending note is, I know the purpose of peace is actually not to create great tech. The purpose of peace is to take care of people. And when you take care of people, then the greatness will follow. So take care of people. So, thank you for listening, and I'm happy to take questions. Yet.
We were talking about the going back to the clean state. Can you rewrite the graphs like in the old days? I'd do like a whole lot of things, and there was usually a flow like that.
Oh yes.
But then if you want to go back to the clean state, sometimes you can just
just kill everything, right? Yeah.
You don't want to waste time doing it. I do the same thing as
Yeah, instead of remove each row before you delete the table, right? Yeah, so it is possible, it's even possible now. So when you send your flow into peace, you tell it which steps are part of that flow. And if you have certain steps which you don't care about cleaning up, you can create a different cleanup command which only contains the steps which you really need to clean up. Yeah, so we can send that in.
So this is awesome. Nice job. Um, I was wondering, so if I want to make any kind of environment, do I write it?
Right now, yes. So I do have the idea of what if we had config-based items,
Yeah,
and yeah. So I think that's a bit far off, but because I think I need to have the code-based items more stable before I move on to the config-based. And the reason why is, one, when you have the code-based items, then you get the compiler support. And if you've coded in YAML before, I mean, YAML is not a coding language, but if you've done CloudFormation, you know how painful it is to get your YAML right? And so I want to stabilize the coding support first, and then work on the config support.
Does it just support Amazon?
Right now, it doesn't actually support Amazon, but it supports everything, as in the trait you saw earlier, the item spec trait. This allows you to manage pretty much any state, and you have to tell Peace what that state is. And so if you want to manage a file on disk, I actually had a different example where downloading a file is idempotent if you just tell it the file on disk plus the e tag from the server. If it compares the e tag from the server with the last time it downloaded the file, which it'll save the e tag the first time it downloads the file. If they're the same, then you should be able to trust the e tag that the file is the same as the one on the server. So essentially, one of the things I wanted this Peace framework to be is it should be as easy as reaching for a bash script, because we know we see, oh, this workflow, I've done it so many times, I can quickly script a bash script to do what I do. And the way that we would do that is the apply the do it function, right? The do work function. If we feature gate all of the other functions, the automation developer shouldn't have to define all of the other functions, and they just define the do the work, which means it's just like your bash automation, just do the work, do the work, do the work. And if we feature gate the others, and then there would be they can incrementally enable those features and add resilience as they need to. Kind of answer?
Oh, yeah.
Mm. Yeah. As long as you've, yeah. Except the real code has 8 functions and is split out into 5 different traits. I do want to consolidate that into one trait, because the split wasn't, the complexity didn't actually give any value. So I will be condensing that back into one trait.
So I use Terraform quite a lot.
Have I used Terraform? I've only done the tutorial. I know it's quite nice, but I haven't used it for like proper long term.
Yeah, so you know, there's a problem between them because there's a lot of great features there. It's kind of overlapping with Terraform. So what is the killer feature comparison for Terraform music? How can you tell it to me?
So I guess I can't really compare Terraform fairly if I don't understand Terraform, but I know that they do. Well, one thing that you saw was progress bars, right? I know what Terraform does is, if you want to see the diff between current states and what you're going to apply, they're going to show you everything.
Yes.
And to a user, that can be overwhelming. And that's why the diff command, it shows you just enough for you to understand, oh, these things will change. And if you do want to look at the detailed view, you can. We do keep the state.
Yeah, so most, okay, that's more like a UX because from the Terraform
Yeah. Yeah. Pulling down state and then like generating what it should be would be a really nice feature. I haven't actually explored that, but I've seen the concept.
And also, it sounds like you're relying on to develop something. But what is the word in trust? Implement the trust. Yeah, to do
Mm. Yeah. Mm. Yeah, I think that would be similar to most state management tools. Like Terraform has providers and Puppet has also providers. Yeah, yeah, yeah. Mm. 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 Yeah, yes, yes. So of course, side project versus company. I'm like, okay, they'll probably win. Yeah. Yeah, sure. Cool. Yeah, yeah, maybe that. Cool. One more question? Yeah. The software developer has to tell it. And there's a little bit of cleverness between that as well. It doesn't just use the logical dependencies that the automation developer tells it. If you both depend on the same data, then Peace will automatically stagger one node from the other. Yeah. Cool. That's us. Then, oh yeah.
So for the piece framework, is there any current commercial application that uses framework to achieve automation?
No. So this demo is probably the most implemented tool. Yeah. I would like this to actually be usable at work because I tend to write a lot of these small scripts, but never do I reach this level of resilience. And well, you need some work buy-in, but the framework itself needs a lot of work. And if I'm working at work, then I wouldn't be able to develop this. So any features would take a bit longer to develop.
Do you have like automated testing for your interruptions and rollbacks?
Do I have automated testing for interruptions? Right now, no. But of course, I do want to put that in because the more you have automated testing you have, then the more you don't have to do the work. And so I know to go faster, you must improve at every step of the way. I know that the 80-20 principle is you get 80% of the work done for 20% of the effort. But if you actually implement the 100%, then you never have to think about that concept ever again because the automated test will test it for you. And one of the other things I try to build into the framework is compile time errors. So I want to not have to run the tests for the tests to be run. So I will just show you one example of that. If I go to, I think, and deploy flow. All right. The way to get compile time correctness without running tests is to write proc macros. So if I save my source file, I get a compilation error. So I know that my ID is incorrectly fed into the framework. And so I didn't even have to run a test to know the ID is wrong. So it's in a matter of like seconds that I get feedback, not in a matter of like tens of seconds or minutes. And of course, the errors must be English enough for me to know how to fix it. Right. Any more questions? Cool. I think that's us. Thank you for listening, and we'll move on to the next talk.